Okay, good day, good morning, good afternoon, good evening, whenever you are watching this. Welcome to today's class on BuildHub, and we are back powerfully. Now, in previous classes, we have gone over strings and integers, variables, printing, how to work with strings, how to work with integers, various methods and things we can do, etc., etc. So today we'll be going to look over some comparison operators. Comparison operators, in the sense that things you use to compare, but yeah, let's get into it. Let's get into it right now. Okay, so what are comparison operators? Like I said earlier, operators, um, let's just look at it granularly as English speaking people, I presume. So what does comparison mean? Comparison simply means the act of comparing. I don't want to use comparing to divine comparison. Comparison simply means the act of weighing two things side by side, or juxtaposing in a sense. I hope juxtaposing is easier to understand than comparing. But it's like saying, okay, what's difference between these two things, what's similar, that kind of thing. So comparison operators in Python are basically used to compare values. Now these values can be variables, it can be strings and integers, and you'd see that now. You'd see that now. So comparison operators, we have some of them listed on the screen already. So let's go through them one by one. First, we have the strict equality. I like to call it the strict equality, or like the equality of comparison operator, but anyone you want to call it is better. So basically, strict equality compares if two values are equal, if the value on the left side is equal to the value on the right side. Now, keep in mind something very key. Anytime you use a comparison operator, if you compare two values and you print that comparison, you will always get a Boolean, in the sense that you are asking the Python interpreter a question. Are these two things equal? Are they not equal? Are they greater than, less than, etc., etc.? I except or and not, but yeah, let's look at this. Let's look at how we use all of them. So like I said, the first one is the strict equality. So let's say we want to compare two numbers. Let's say 6. The number 6, is it equal to the number 8? Well, we know as mathematicians that 6 is quite in fact not equal to 8. So it's like we're asking the Python interpreter, is 6 equal to 8? Obviously, the answer to that is no. So if we were to print this, we would get false, which is the no equivalent in Python, 0. So let's run this. Exactly. We get false. So this is false. What if we did 8 is equal to 8? Well, 8 is actually in fact equal to 8. So if we run this, we get true. So yeah, that's basically how the strict equality or the equality operator works. Now, a question for you. If I did this, what do you think the output would be? Just think about it within yourself. What do you think the output would be? Well, let's check it out. Now, if you noticed, we got false. Why is that? Because in as much as the digits are the same, we have 8 here, 8 here, the data type is not the same. So the strict equality operator performs on two levels. Firstly, it checks the data type. Are the data types the same? This is a string, this is an integer, are those the same? If that is no, then it's false. If they are the same data type, then it goes further to check, are the digits or the character the same? Well, the characters are the same, yes, but it didn't pass the first step. It didn't pass the data type test. That's why it outputted false. So keep in mind, string 8 is not equal to integer 8. Just keep that in mind. They might be the same character, but they are not the same data type. And the strict equality operator works on data types first, then characters. All right, so let's look at that. So this, if this is equal to, what do you think this will be? Well, this would be not equal to. That exclamation mark simply is inverting that. It's simply saying not equal to. So if I print this, what do you think we'll get? We'll get true, because in fact, this is not equal to this. Like we said earlier, this is a string first, and this is an integer. So they are in fact not equal. So yeah, Generally, when you are comparing between two data types, even if it's a Boolean, even if I put this as a Boolean, it would still give me false. Sorry, it would give me true rather, because they're actually not equal. So first, any equality operator checks the data type first before it checks the character, even though this fails on both counts. But just understand that when you're comparing two data types, they can never be equal. And that's something to check for when you are having a variable. So always make sure that your variable is of the correct data type. You would see that in further classes how that can be an issue, but this is one of the reasons why I should do that, or rather, it's one of the ways you can check that. Okay, so I've covered the first two. Let's cover the third one. Now, or. Or is simply saying, or rather, let's leave or and not for later. Let's cover the normal ones first. So now we have greater than. Let's take two numbers. So is 9 greater than 8? That's what we're asking the Python interpreter right now. Is 9 greater than 8? Well, we get true because 9 is in fact greater than 8. What if we did 9 less than 8? That would be false because 9 is actually not less than 8. So it reads just like your normal math. It reads just like math. That's greater than, that's less than. Now I am just printing straight into the brackets the values, but at this point in time you'd already known how to work with variables. So we could do something like 6 is equal to 6, and then we could say print 9 less than 6. Remember, it's carrying this value. Remember, whenever you use a variable, it's not the variable itself, it's the value that the variable is assigned to that is being used in that operation. So if we run this, we would get false because 9 is in fact not less than 6. Now we have the remaining two, which is less than or equal to and greater than or equal to. It reads just like your normal math. So we can take something like 9 less than or equal to 9. So what do you think? Well, according to normal math, 9 is less than or equal to math because it's either less than or equal to. 9 is actually equal to 9, so it actually passes that. So if we run this, we have true. Likewise, if we did 9 greater than or equal to 9, we would still get true because 9 is still equal to 9 and it's checking for greater than or equal to 9. So that's basically how all of them work. It's very, very simple, and you'd be shocked the kind of crazy things we can do with this. So let's say we want to create a program to check a person's age, to check if a person is an adult. So you can say, or rather, just pause it and try that for yourself, and then you can pause it here, then try that for yourself. Okay, if you're unpausing it now, I would like to believe you have done this. So let's look at how we would implement that. So we can say age is equal to, let's make it an interactive program, is equal to input. What is your age? Now remember, you are expecting an integer here. You want an integer. So this is something that you'd have to keep in mind. So you have to wrap this in int because you're expecting an integer, even if you get a string. Ordinarily, the input, rather, whatever you pass into an input statement is usually a string. Python reads it as a string, so you have to typecast it to an integer because that's what you're expecting. So print age greater than 18, which is, of course, the age of adulthood in most countries. So if we run this, and it asks me what is my age, I tell them my age is 9. It tells me false. I'm not an adult. So we could even make this better. We could make this better. We could say that adult status is equal to age greater than 18, and then we could say print Are you an adult? Adult status. I'll just put formatted strings outside this. And then let's just clean this up to make it look better. Beautiful. So let's try this again. What is your age? Let's say I'm 16. Are you an adult? False. That is in fact true. I am not an adult. But if I run this again and I put something like 19, are you an adult? True. It's as simple as that. Now, going further, you would see there's a more succinct way to do this using if statements, but that is not our scope for today's class. So that's basically a program you can use operators to create. Very simple, very fun, and you'd be shocked the amount of things or the amount of logic you can build with these. Going further into if statements, you'd be able to, if else statements, you'd see how powerful they are. But finally, let's close out on this and look at or, and, or not. So not is simply used to negate something. So if we printed not true, let me just delete it. And if we printed not true, you would have false. The not statement is simply used to negate whatever is next to it. It's as simple as that. Usually it's used with Booleans. It's most exclusively used with Booleans to negate it. So if you have something that is giving you true and you probably want false, you just do not of that. That's basically what the not implementation is. And then and. So let's print true and false. So what do you think it would give us? Well, from our propositional logic from mathematics, we know that for and to give you true, both the entities in question have to be true. So this is true and false. True and false cannot stay together because they are both not true. So it would output false. Exactly, it gave us false. That's how and works. But if we used or, well, we know for it to output true, just one of them has to be true. And yes, we have a true value here. So if we did that, we have true. Again, Python reads just like your normal English, just like your normal math. It's simply things we already know that we are building upon or we are programmatically representing into the computer. And keep in mind, this doesn't have to be true or false. This could be a variable that's holding the value true, and it could be a variable that is holding the value false. For example, day could be equal to true, and then night could be equal to false. So can it be day and night at the same time? Well, let's check that out. If we run this, well, sorry, not or, and. If we run this, we have false because it cannot be day and night at the same time. But it could be day or night. It could be either one of them. So if we run this, we have true. So that's another implementation of it. Again, this is just a boilerplate example to just get you to understand it. But yeah, all these things, they are the backbone of programming logic, especially if you want to go into machine learning. This logic is very, very important in terms of statistics. But yeah, thank you for today. That's basically everything on comparison operators. In our next class, we'll look at lists and dictionaries. Yeah. Thank you for giving me attention. Thank you, thank you, thank you. Have a wonderful day, morning, afternoon, evening, and night. I hope to see you in the next class, and don't forget to like and subscribe. Thank you.